And welcome back, everyone. This is your instructor, Dr. Rodriguez. We continue on with our brand new ladder logic programming class. And of course, as I said before, we are actually studying sort of two languages in this course. One is the idea of relay logic, and the other one is the idea of ladder logic. Relay logic is nothing else than standardized schematic representation of electrical control systems that can somehow be converted to ladder logic. And that's our purpose here, to give you a background on electrical control systems, at least the interpretation, understanding, reading part of it. And then from that schematic, allow you to convert that into a automated ladder logic programming system. So we are here in our second lesson, and the second lesson is really the justification of using PLCs. What are some of the reasons to use PLCs? Why do somebody want to use PLCs and not other conventional electromechanical control systems? So I'm going to talk a little bit here and give you some ideas on what the implications are. Before we go on, think about the old days of computers, the ENIAC, the computer that was invented at first, and one that, according to historical information, it was hosted in a large room, and it consisted of multiple wiring systems, power supplies, tubes, and things like that. And it wasn't very effective. It didn't have much speed, much capacity, dealing with information and so forth today. So we have today more power in a $1 calculator than what we used to have in a computer when it was invented. The same idea is true of controllers and other means to control machines and systems. So in a nutshell, one person, one company, one individual will decide to use PLCs in essence because of these 7 aspects. One is the reliability that those devices have. 2 is the level of simplicity that you can have with it. 3 is, of course, when you have the ability to communicate devices with other devices. That's pretty powerful. And 4, and most importantly, probably, is the economic reason. And then, of course, they're very, very versatile. They can be used in a variety of different situations. And of course, when it comes to troubleshooting and diagnostic automated control, electronic control systems, a PLC is a good option because it's got a way to be able to navigate through that system. And when it comes to actual applications, is the speed of operation. So all these things are some of the reasons, and there's probably more, but these are some of the main reasons why I or you or somebody else want to go with a PLC versus another system. All right, reliability, simplicity, communication networks, the economic aspect of it, versatility, the ability to diagnose and troubleshoot the controller itself, and the speed of operation by which the controller itself works out. Okay, those are important characteristics. And this is probably a great example right here. You are seeing a picture in the background that shows you an old-timer electromechanical control system. I work big time with these controls, and they can be dangerous, right? Because they're high power level. They can be complicated because there's so many wires involved. They dissipate a lot of heat. And so this is the old and traditional way to do controls. And this is the new and modern way to do controls right here on the right-hand side corner. A controller that has just a little tiny capacity as compared to this modern controller right here. So we talked about the economics, and there's actually a basic rule of thumb. When do you want to use a PLC? Even in these days where controls are permitted and allowed and needed, there might be occasions where high power rating is required. You might use traditional control systems, or where the economic justification doesn't really match. So in this case, we got 4 big motor electromechanical control relays. And the basic idea here is that anytime I have more than 4 electromechanical relays of any sort, then that application it's a candidate for a small compact PLC such as the one we're seeing in this case. So if nothing else, the most obvious reason here to use a PLC-based control system versus an all electromechanical system is look at the space and look at the wiring and look at the so many parts that are involved. And as the story goes, every time I have more components involved in a system, I increase exponentially the chances of my system going wrong. So you can tell with this picture in the background of this electromechanical control system, with so many wires, how many different situations can go wrong. And that really, right there, is enough reason to be able to justify the use of a controller. So just refreshing back here, when somebody asks you, why is it that I want to use a PLC and not other means of control systems to control machine or process, you can just recite these ideas. You can really expand here on what we're talking about. You want a piece of equipment that is reliable. We talked about that when we saw the background picture of that electromechanical control system with so many wires. So at the same time, you want something that is very simple or simple enough to be able to install it and know that's going to work okay. We also want to have something that can use current technology, and we're talking about networking technology. And today with controllers, one of the most powerful ways to daisy chain or program multiple controllers with the same instructions is by means of communication networks. And so networking is really a big deal when it comes to controllers. The economic is really a huge driver for the use of controllers. It's an obvious reason, actually. The fact that controllers are also versatile. They can be used in a variety of different kinds of applications. It's rare not to see a form of an electronic control system in a machine or process today. You're going to always see that. And of course, these last two items, I don't put them here in the last part of my list because they're the least. Actually, they're probably some of those the most important features for the reasons to use controllers. And that is, when you're a plant engineer or maintenance personnel person, you really want to have the right tools to speed up the process of getting the machine or process or factory back on working. And so diagnostic and maintenance is pretty powerful also. But also at the same time, speed up operation. You want to be able to count parts or events while you can keep up with the speed of production that you have. And for that, I think I got a couple of pictures here. Wanted to show you. Here's an example of a controller, really a tiny piece. Notice the difference between what we saw before. Simplicity of wiring here, right? Not only that, but we have the ability to diagnose and monitor what's going on in the process. That really is a pretty powerful feature, especially for those of us who are the installers, troubleshooting maintenance people and engineers. We want that feature so we can actually diagnose that control system on the fly as is working, so we can learn what things need to be corrected and what things need to be changed. So that is really a powerful feature when it comes to controllers, and the reason why I want to choose a controller versus another very desirable feature when it comes to controllers is that they operate in real time. And what I mean by that is, if you have a fast production of something, you're producing tea bags, you're producing pop, you're producing drinks, whatever it is you're producing, you want to be able to track that production. In our case here, we got a sensor on top and another photocell here that keeps track of the number of boxes. And then we got the photoelectric sensor right here. Then we got a counter, which possibly could be a counter built in a controller, or a counter which is a module of a controller. We want to be able to track that so that when the production is going on, my controller can work in real time. Now, you can hardly track that with other systems that are slow, that are not electronics, and that they don't work as well as the controller works. So we're saying that there's plenty of reasons to justify why use PLC controllers. All right. So in review, we can say that, again, there's a list of 7 reasons, all of them pretty powerful, but if you want to nail it down to 3, I'll say economics, one of the big reasons, diagnostic and maintenance, speed of operation, and then along with that, you have, a piece of equipment that is versatile, can be used in many different kinds of applications, is reliable, is simple to install, and of course is able to be connected to modern communication networks so that we can do more things and more powerful things with it. So this is our second lesson. We're going to stop here. And the idea here is, why do we want to use PLC controllers and not other conventional old-time electromechanical control systems? And these are some of the reasons why we want to do that, right? So thank you for your time, and I will see you during the next lecture coming up soon, right? Dr. Rodriguez with you. Thank you.